Welcome back everyone, Patrick here, and moving on to the next example. So for each of these equations here, they're equations of circles. We have to state the radius of the circle and then provide a coordinate on the circle. So notice that all of these, they're in the format x squared plus y squared is equal to r squared. So that's the general format for a circle, where this r over here is the radius of a circle. And so the first thing we have to do with all these is get the radius. And so notice that the radius is going to come from this right side. And so we know that r squared in this particular case is equal to the 4, or the radius squared is equal to the 4. So if we want to just get the radius by itself, what we would do is just square root both sides, and then the r would be 2. And we always state the 2 in terms of a positive, right? Usually the square root is plus or minus, but when we're finding the radius, we just take the positive value. Okay, so the radius for number 1 for that circle is 2. Now, how can we get a coordinate on the circle? Well, multiple ways to do it. What we would do is actually just use the equation x squared plus y squared is equal to 4. And what you can do is you could just pick a value either for x or y, plug that in, and then solve for the corresponding other point or other part of the coordinate. So for example, let's say that we pick 0 to plug in for x. Okay, so we would plug in 0 squared, and then we would solve for the y. And so what would we get here? 0 squared is just 0, so we'd end up with y squared is equal to 4, and then square rooting both sides. Notice the y in this case can be plus or minus 2. And so with an x value of 0, you can have either a y value of positive 2 or a y value of negative 2. And you can confirm that on the graph. So if we graph this, notice 0 and 2, let's say that's like right there, and then 0, negative 2 is down there. Now what if those are the y-intercepts, right? If you want to plug in 0 for x, find the y-intercepts. What about the x-intercepts? Well, we would then plug in 0 for y. Okay, so what would happen then? We would have x squared plus 0 squared is equal to 4. So we'd end up with x squared equaling 4. So x would equal plus or minus 2. So when y is 0, x can be plus 2 or minus 2. So it could be 2 and 0 or negative 2 and 0. So if we draw those points, over here would be 2 and 0. Over here would be negative 2 and 0. And so if we draw these, the circle is going to look like that. Now, the x and y intercepts are pretty easy to get. You're just plugging in 0 for x and y. But what if we wanted to get another point on the circle besides these x and y intercepts? So what if we plugged in a value, let's say, of 1 for x? So then we'd have 1 squared plus y squared is equal to 4. So then 1 squared is just 1. So we'd have 1 plus y squared is equal to 4. Bring the 1 over. So we'd have 4 minus 1, which would be 3. And then we would square root both sides like that. So y would end up equaling plus or minus root 3. I'm going to leave it as an exact value, but if you wanted to get the decimals, it'd be plus or minus 1.7 approximate. And so these coordinates here, if we write them out, well, at an x value of 1, we could either have plus root 3, or at an x value of 1, we could have negative root 3. So we could either have 1.7 if we put in decimals, or 1, negative 1.7. You may see either or coordinates given. So at an x value of 1, which would be like over here, well, right here, you could either have 1 root 3, or down here, you can have 1 negative root 3. Right, so that's an example of how you can get other coordinates within here, not just being x or y intercepts. You just got to make sure that you're plugging in values that are within these x and y values. So for example, let's say that we tried to plug in an x value of, let's say, 3. Well, notice how the maximum x value we can have is 2 right here, right? We can't have another x value that's greater than that or less than -2. So what would happen if we tried to plug in 3 for x? Well, we would end up with 9 over here. Bring the 9 over, and we'd end up with -5, and you can't square root a -5, so you wouldn't be able to get a corresponding y value. So an x value of 3 lies outside of the circle, right? So you wouldn't be able to get a coordinate with an x value of 3. Same thing with a y value of 3, because the limit on the y value is 2. The upper limit and then the lower limit is -2. So what you have to plug in for x and y is something between -2 and 0, inclusive of both of them. That's called the domain of the circle. And then what you could plug in for y is something between -2 and +2. That's the range for the circle. Right? So that's how you can get certain coordinates. Sometimes they'll specify that they want certain x or y values. Sometimes you'll be able to choose, and then you could pick anything you want. Right? So that's a few coordinates on this first circle. Now, what about the second circle? Let's start first with the radius. So notice that r squared is equal to 49. So that means the radius is 7 for the second circle. And then if you wanted to get some coordinates, again, you could plug in maybe 0 for x if you want to get those y-intercepts. And you'd end up with plus or minus 7. So some coordinates are 0, 7, 0, -7. Or if you wanted to get the corresponding x-intercepts, you'd plug in 0 for y. And then you'd have x squared equals 49, so x can be plus or minus 7, so you'd have 7 and 0, -7 and 0. And then you could plug in other points. So if we draw this circle first, let me draw these intercepts first. So we have this, this, this. So we got 7 and 0, here we got 0 and 7, here we have -7 and 0, and here we got 0. -7. So if we draw this circle, roughly, we end up with that. Let's say that we wanted to get maybe like an x value of 6. So if we plug in 6 for x, we'd end up with what? 36 plus y squared is equal to 49. Bring this over. 49 minus 36 gives us 13. So y would equal root 13, plus or minus root 13. So it'd be like 3 point something. That's what the corresponding y value would be. So a couple of coordinates are x and positive root 13, or sorry, 6 and positive root 13, and then 6 and negative root 13. So that would be like here, right? An x value of 6. So this here would be 6 positive root 13. This here would be 6 negative root 13. Okay, what if we plug in something for the y values? So let's say we plug in, I don't know, let's say 4. Right? We want to get a y value of 4. So a y value of 4, let's say that's like over here. Okay, so we would end up with x squared plus 16 equals 49. Bring the 16 over. and that would be 49 minus 16 would give us 33. So x can be plus or minus root 33, like that, which is going to be 5 point something, between 5 and 6. So let's say this is not to scale. I just don't want to mess around. Actually, you know what? Let's erase these points here just to kind of clearly show what's going on. Not to confuse you, but let's say a y value of, we used 4, so a y value of 4 over here. So what we're doing is we're solving for the corresponding x values. Again, this is not to scale, but what we just solved for here are these two x values. So notice that the two coordinates are positive root 33 and a y value of 4, or negative root 33 and a y value of 4. So that would be like over here. So this would be negative root 33 and 4. This here would be positive root 33 and 4, like that. And you can also get the decimals if you want. Usually these coordinates are shown in exact value form. Right, so that's an example of how you could take a circle, find certain coordinates. Just make sure you're picking x and y values that are within that domain and range. For example, if we pick like an x value of 8, plugged it in, then we would end up with a negative on the right side. Can't solve for that corresponding y value. All right, and then finally, number 3, we have x squared plus y squared is equal to 80, so that means r squared is equal to 80, which means that the radius would be the square root of 80. Again, you could also get the decimal. Now, as an exact value, it's root 80, but you can actually simplify this exact value. Your teacher may expect you to know how to simplify them, may not. So just in case they do, the way you could simplify this, well, you could break down this 80 into root 4, root 20, for example. So that would be 2 root 20. So root 80 to root 20, those are the exact same thing, right? 4 times 20 is 80. And then you want to break it down into a rootable number. And then actually the root 20, you could further simplify into root 4, root 5. And then we would have 2 times 2 times root 5, right? The root 4 ends up being a 2, so this would be 4 root 5, right? So this and this, if you plug them into your calculator, they'll give you the exact same values. If you didn't want to do all these steps, if you wanted to just get here, you can notice that you could break down root 80 into root 16 times root 5, and root 16 is a rootable number. That gives us 4 root 5. Right, so you may see the radius given in different formats in your textbook, or your teacher may give it in different formats. You might see this, you might see that, you might see a decimal. So just in case they do give this or something like this, this is the process that they are going through. Right, so that's the radius over here. I'm not going to draw out this circle, same process that we were using before, but let's find another coordinate. So let's pick maybe an x value of 4. So we could pick an x value of 4, solve for the corresponding y value. This would be 16. Bring the 16 over, we'd have y squared. 80 minus 16 gives us 64, so y would equal to the square root of 64 would be plus or minus 8. So this is a nice point because they're two integers. Right, so we can have 4 and positive 8, or 4 and negative 8. These two coordinates are going to be on the circle. What if we use maybe, let's say, a y value of 5? So we would have x squared plus 25 equals 80. Bring that over, we'd have 55. So x would end up equaling plus or minus root 55. And then this over here, I don't believe it simplifies any further. It doesn't divide by 4, doesn't divide by 16, doesn't divide by 25. So root 55 would be the exact value. If you wanted to get the decimal, it'd be 7 point something. So two other coordinates would be, for example, root 55, and then we plugged in what? A y value of 5, or negative root 55. And we plugged in a y value of 5. All right, so you can graph this, and then these points are going to be on it. All right, so that's the process of getting the radius for a circle and getting a coordinate